Okay, thank you for coming. As Stuart has been pointing out to me, we appreciate that you have a choice of presentation to attend, and we're very glad that you took our flight. So this is the 10 simple rules of writing great test cases. It's a talk, as you'll see, which is a joint talk between us, and mostly we agree, in a few places we probably disagree. We will try to keep to time, but if blood starts flying, then there's the door. So this is me, Steve Poole. I work for IBM. I've been working for IBM for, I think, all of my life. I feel like I've worked for IBM for 50 years. I've been a JVM developer for the majority of that time, so I don't know, 25 years. And I did a bit of DevOps for a couple of years, and that was fun. And now I'm back out being developer advocate for Java runtimes and things like that. So I have a lot of experience with much of the pain that we're going to talk about. Stuart?
Okay, hi, I'm Stuart Marks. I work for Oracle on the JDK and OpenJDK and Java group. I've been working on at Oracle and previously Sun Microsystems for as many years as I've been working long enough that I have to do the arithmetic to, so pretty long time. So yeah, along the way, I've done a lot of, have a lot of experience developing and debugging test suites, and a lot of experience gained from that.
Cool. Right. So first question: how many people here write code?
Okay, good, everybody.
How many people here write tests?
Excellent.
Is that the same hands?
It looks pretty much the same hands. Yeah.
Cool. So, what to say? There are lots of people out there who think that their job is to write code and not write tests. And we're going to go through these 10 simple rules that are going to explain to you that actually you have to write tests, which we all know, and the guidelines that we think you should be following when you're writing good test cases. And we think some of these you may consider to be teaching yourself to suck eggs, but actually we think some of these have good reasons for still existing, even in the modern world with cloud and containers and stuff like that. And a lot of this is all about this sort of bit in the middle. How do you maximize your effort when you're writing test cases? How do you get the best out of it? Right, so, do you want to say anything?
Yeah, I just wanted to add, I mean, so part of this, so you all of you write tests, so maybe you already understand the value of writing tests, but sometimes there's an argument with somebody who perhaps is not in this room, which is why you bother writing tests, because like the slide says, I get paid for writing code, not tests. And the thing that I've learned over the years is that the tests end up knowing more about the code than you do. So when you're working on code, you run the tests, and hopefully all the tests pass, and we'll talk about good test cases and stuff. Yeah. But occasionally, I'll make a change to some code, and I will be surprised because it causes a test to fail. And that's a reminder that the test suite knows more about what the code is supposed to do than I can keep in my head at once. So it's a continual reinforcement of the value of having good tests and a good test suite.
Yes. So unless you have a really big brain, you soon find, what do you think it was, like 200 lines of code? And it sort of got to the point it was out of your head?
Yeah, it was just a toy exercise I did where I was just, adding, it was a kind of a TDD exercise. Have a little toy program, write a test for a feature that doesn't exist yet, fails. Implement the feature, now the test passes, everything's green again. So that's the test-infected exercise that's been around for quite a long time. And I think I did this 15 years ago or something like that. But when I did, I quickly got to the point where I was surprised by failures that I caused. And so what that was telling me was that there was more knowledge in the test suite than I could keep in my head at once.
Yeah. I could say things, but there we went.
Yeah, okay.
Okay, so here are the 10 rules. As you'll see, what we think these are sort of like pirate rules, and we'll explain what that means at the end, but you may get the joke already. So here's the 10. We agree and disagree about the order and what should be on the list, and maybe there are others that should be there or not. But we're going to go take you through, and you'll get to see our opinion. So let's start with the first one. Think before you act. Okay. So you think when you're writing test cases, it's very easy just to start writing test cases. And this piece, this is obviously the first thing. Before you start writing test cases, you need to know what you're trying to achieve. Okay? And the other rules, the other 9 rules, will fit into this because they're all reflections of why you're doing all this sort of stuff. Okay. So as Stuart said, he wrote some tests for a little tiny thing, and he found out that actually what he was doing was he was capturing the behavior of the system. Right? And that's what we're doing. Right? Tests are, at one level, sort of like the inverse of your code. This is your test captures. You've embodied in your test what you expect the behavior of the code to be. So when you're writing tests, you should be thinking about the most effective way to do that. Right? What you don't want to do, lots of people do, is they go, oh, I'll do code coverage or test coverage, and I'll do the easy bits. I'll write tests for all the getters and setters because that's easy. And it's like, well, that doesn't really help because they're going to get tested anyway. What you want are test cases that explain to you and to your descendants when they pick up your test suite what the test was trying to do. And obviously what it's trying to do is exercise the code in a particular way. So we also talk about, you don't use this, we talked about testing quality in. No. So if you're going to test your product, do you use test cases to test quality in? And we had a good conversation about what quality meant. And so that's what we came up with. More likely, this is about writing test cases for embodiment of the behavior of your system. And you only have so much time. You get, as like the quote said at the beginning, you only get so much time to do this. If you spend all your time writing simple test cases, you're not doing yourself a favor. So you should forget about those sorts of things and focus on the important activities that you should put in your test suite, not the bits and pieces. So Stuart, what do you think about, we had this conversation about testing in quality. Do you think that's a reasonable thing to achieve, or do you have an opinion?
Right. I think there's definitely have an opinion.
Yeah.
There's a subtle relationship between testing and quality, and I think it's very interesting listening to people talk about them, and there's a lot of subtlety is often lost in those conversations. And the way I think about it is that you spend a lot of time talking about quality, but this is not a quality talk. This is really a talk about testing. And so testing is a measurement of one aspect of quality, which is the functions that you intended to do. And so if you have some software, you intended it to perform some functions, tests are verification that those functions are implemented correctly. Now, whether those functions are valuable to the customer or whether they run fast enough or something like that, that's kind of a separate issue and other aspects of quality that we can't cover here. But I think it's a measurement or a verification of functional aspects of a system. And occasionally you run into, I've certainly run into project managers in the past where, they'll say, this product doesn't have enough quality, or this product is low quality. Therefore, we should write more tests. And it's like, no, that's not quite right. There's something more fundamental going on there. Yeah. Now, maybe if it may be that hypothetical project needed to improve its quality, and so a bunch of things happen to be, bug fixing or better, better design or refactoring or something, and as part of that effort, better tests need to be written. Maybe fewer tests need to be written. Some garbage tests might need. So a whole bunch of activities regarding testing might have needed to be done as part of a quality improvement effort. But just writing more tests does not improve quality as a cause and effect thing. So sometimes that's what that means. It's like, can you test in quality? No, you can only test the quality that is already there.
Yeah, and we all know if you write more tests, you find more bugs. So if you try to test quality, you'll never finish because every time you write another test case, you probably found another bug. Okay, so let's move on to number 2. Stuart, do you want to kick this one off?
Yes. Okay. So make your tests understandable. So here's a bunch of interesting things about code quality, comments, behavior diagnostics, and so forth. And so what this is asking really is, what's the relative importance of your tests versus the quality of the code in your product? And occasionally you'll hear somebody say something like, okay, there's this code in this test over here isn't very good. Maybe we should go clean it up. Nah, that's just test code. We don't need to worry about that. And I think that's a mistake because tests are just as much a part of the software system as the product is itself, because you need to understand it, you need to maintain it, and as you evolve the product, you also need to evolve your tests. So both are living things. And so I think it's a mistake to say, gee, that's test code that's unimportant, because that will get in your way in the future. So Steve, what happens if your test code is not well maintained and not understandable?
You spend a long, long time trying to figure what's going on. So if you have test cases that you can't understand, so I go back to the first point about the testing of your test as an embodiment of the behavior of your system. So if you read a test case and you go, I don't know what it's trying to do, well, then how do you know that it's supposed to work well at all? Okay? You get it, somebody says, my test failed, and you go, is it because it's the wrong test, that it's badly coded? Is it just because you don't understand how it works? So if you don't make your test understandable when you write it, you know, it's like when you come back tomorrow or 6 weeks' time and you try and understand what's going on, you go, what did I do that for, right? So the other way of looking at this is this whole thing about debugging your application takes twice as much brain power as writing it. So we should only use half a brain in writing the code, okay? And I could point out that actually it's the same as testing, right? If you put all your effort into fantastically hard code, then your tests are going to be fantastically hard times 2, and then you have to remember how to debug those. So if you add it up, you know, if you have really complicated tests that you don't understand, you need 4 people to figure out whether it's working or not. So you have to start right at the beginning. So it's simple, easy, well commented, understandable tests. Right, number 3. So related to that, keep your tests small and simple. So what we mean by that is where if you look at tests, sometimes it's really hard to work out which bit of all this code is the test. Right? Now, it's easy if you've got frameworks that have got like JUnit that can do assertions and things, but if you don't have that, or you only have one of those, and you go, I've seen tests where there's lots of if statements, and then there's an assertion that says this thing should not be null. And you go, well, yeah, but which bit of all this code did it work it out, right? So you want to start thinking about, you want to keep it separate. So a lot of these frameworks have great setup and tear down stuff. You know, it's so much easier. You separate out your tests, you keep them as small as possible, makes it easy to understand, and as you'll see later on, actually means execution benefits. Yeah. You agree with that?
I think so.
Cool.
Yeah. I think I mean, it's one of these things. It seems sort of obvious. Structure your tests. You have setup, perform an operation, make some assertions about it, then tear it down.
Yeah.
But it's obvious until you run into a test suite that you inherited from somebody else, where that wasn't followed.
Yeah.
And then it's sort of, this test is doing a bunch of stuff. Okay. Well, what is this testing? Right? Is this the setup, or is this an assertion, or something? Right? And so anyway. So yeah, do this.
Do this, yes. Okay, so I think you're next. Yeah.
Am I next? Yeah, test one thing only. Yes. Okay. Oh, right. Okay. So yeah. So actually, that's kind of a continuation of what I was just saying. And so when you have a test case that has this well-structured setup, operation, verification, and teardown, then put only one operation or one test scenario in each test. And I think it's a very important rule to follow, but it's also a little more subtle. So even if you have a well-structured test, what I find some people do is they say, okay, I have some setup code, and I do an operation, and I do some assertions. Well, while I'm here, I'll test this other thing and do some assertions on that. That's right, there's that other thing over there, and I'm going to do some assertions on that. So they end up piling a bunch of operations and assertions into the same test. And the problem there is that now you're mixing a bunch of different concerns. So maybe the third operation actually had a subtle dependency on the first operation being performed correctly. And if it didn't, then if your first operation left something in the state of the system or the test fixture that wasn't caught properly by an assertion, it might cause a failure downstream. And now you have a big debugging chore on your hands. So maybe you got an assertion halfway through, and it's like, well, why did it get this way? Now, instead of saying, okay, I have some setup and perform the operation, and then you can go in with the debugger or logging and tracing and figure out what's wrong at that point, you have to go through all of the stuff that led up to it in order to get to that point, because you haven't separated out all the different test cases that were being that we're being tested for there.
Yeah.
So now, Steve, do you agree with that?
Well, yeah, I do.
This is terrible, not enough controversy.
So I'm just thinking about circumstances where this has been broken. And one of the things I've seen over and over is test cases that have 100 asserts in them, right? And then there's another test that's got 50 asserts, and you go, you've got the same ones. People get carried away. It's very good to write asserts to say, I've just called this method and it's returned something. Is it null? I'll do an assert. It shouldn't be null. And that's great. But then you also have a test somewhere else where the same thing happens, right? And it's like, why are you doing that, right? When you want to do, what you want to be able to do is go, it's very clear to me what I'm testing. Is that test testing the very first assertion or the very last assertion or all of the assertions? Now, there are times when it's reasonable, a scenario, to say, I'm going to make a call, I'm going to get a complex object back, I'm going to make some assertions. Because if you don't do that, you might find that you're doing lots of calls to get objects back and you're wasting effort. But if you just generally keep going, assert, do something, assert, do something, then you just muddy the waters. And if you mix your scenarios because it's complicated, then you end up the same thing. So you want obviousness. So obviousness, so you can go, I can see what failed, and then faster debug, right? Which one failed, right? This one here. Let me put a breakpoint on that point, easy to see. If you have to work through the code to work out that's the thing that's important, then again, you fail. Okay, yeah. Fast tests only, yes. So this is a cool one, right? Because you have to think about, the obvious of the opposite. So let's think about testing. So what you want to do is you want to run your tests instantly. That's our nirvana. I write some code, I change some code, I save it, I want things to run, right? We can't do that because we know our tests are, some things are by nature going to take a long time. I don't have infinite supply of compute power. So I want to get away, I want to have to back off that argument and go, okay, I'm going to make some risks. I'm going to take some risk assessment and I'm going to say, I'm only going to run these tests in these circumstances. If you can't ever run test suites quickly, then you don't do that. What you end up is you just start excusing yourself for running test cases. You go, yeah, we're running once a week because they take hours, right? And you just start perpetuating that. So fast tests are, it comes back down to write the least amount of code to do what you want, run the test as fast as you can, right? Because if you don't, you get this sort of attitude. We've all done this. I've made my code change and I've submitted the build and then I'm going to run the test and tomorrow it'll tell me what the results are, right? So we can do things about improving the build and we do focus on that. What do we do to improve the speed of our tests? Actually, we tend to take them out, right? And so let's not get there. Let's start by making sure that the test that you write is as quickly as you can, it runs as quickly as possible. And there are clever ways of doing that, like mock objects and things that reduce the amount of effort you spend to get to the point where your test runs. There's me. Yes, corner cutting. That's what you just don't do this. Have fast tests. I think I've just given away your piece. So, do you have anything to say?
Yeah, I have some things to add. Yeah. So I think that we've been agreeing with a lot so far. So I think the main thing is to get a tight feedback loop between the code you just wrote and the test results. So if you wrote some code and you get some test failures, it's like, those test failures must have been caused by the code I just wrote. And if you can only do that if your tests are fast.
Yes.
If your tests are not fast, the farther apart they get,
yes,
the causation is weakened.
That's true.
Right? And so I've been on projects where the test suite is so big and it's so arduous that we have to have a whole nother test team to run the tests, and they only deliver the tests every 2 weeks or something like that. So you can't sit around waiting 2 weeks for your new feature. So what you do is, I'm going to work on my feature, check it in, and then I'm going to work on the next feature and check it in, and so I'm pipelining my stuff. Then I get the test results, and there's a failure. Which one of the 10 change sets I pushed over the past 2 weeks caused that failure? Okay, now I have to do bisection, and now I have to try to do some, basically I have some detective work that I have to do instead of saying, I wrote some code, test failed, therefore this code is buggy.
Yes.
Right?
Yes.
So
totally agree. So it says if you try, you make your test run as fast as you can, because if you don't, then they will be run by somebody else, because we're all getting to, well, the other test team will run it. It'll do it later. They'll do it less often. They'll do things about trying to deal with that problem, and then you end up with, you have no test to run locally, or you have your favorite set, which is the other problem, is you do, because let's be honest, what developers do, if they have a big test suite, they find the ones that run fast, and they run those, because they can do those in 30 minutes, you know?
I just had a question though, because would you have, in your experience, a heuristic of like how long the test should run before you start worrying about trying to speed them up?
Repeat the question.
So the question is the heuristic about how long you would allow a test to run before you would speed it up? Yeah, milliseconds. Actually, that's the right answer is how long. It's like how big is your test suite? How long does it take, right? So I would say, there's to give an example. There's a project back where I work, and they have been working on moving their test suite time, how long it takes to run the whole of the test suite, and they say going from ski to T. They said it used to take the length of a ski trip to run all their tests, i.e. 2 weeks, right? And they said, this is ridiculous. We need to get it down to how long does it take you to drink a cup of tea, right? And so it's an order of magnitude thing. That makes more sense, you know, because you will run the tests. And if they take too long, you won't run the tests.
Right. So in OpenJDK, we have a test suite that we run regularly from our continuous integration system. And we try to make sure the whole test suite runs in 2 hours or so.
Yeah.
So you can push code multiple times a day and get test results multiple times a day. And so it's less about the speed of any given test than the aggregate. Yeah. But it is something to keep an eye on, right? So if you have, you know, and we have high variability as well, right? We have some combinatorial unit tests that run hundreds of thousands of test cases, and they take a few minutes. Or maybe you have one thing that takes, you know, 100 milliseconds, something like that. But the aggregate is the thing to watch out for.
I mean, to be honest, once you get into test suites that take a long time to run, then you start applying different sorts of techniques. So then you start talking about which of these tests have, you know, do I run this test or versus this test? And it might be how long does the test take to run, but you might go, this test has never found a bug, so maybe you don't run it so often. And that's the domain of, you know, of the system test team who's put their expertise in trying to figure out how they matrix this massive problem so down to something manageable. Right, okay. Number 6, absolute repeatability.
Okay, yeah, so this is a fun one. So this is, I think, you know, you can't be absolute about saying absolute. I think this is definitely something to strive for, but I have to admit that it is probably not possible to achieve in practice. This is something, certainly our experience in OpenJDK is that we have intermittent test failures, and we have been working on this for years, and it is still not a problem. Or, excuse me, it is still a problem. It is less of a problem than it used to be, but it is still a problem. So how many of you run test suites regularly and get intermittent failures? Can we have a show of hands? Yeah, at least 3/4 of the people in the room. Yeah, okay. So that's, you know, it's a tough problem. And so I think the first thing to do is to get an attitude check, because occasionally talking to developers, they'll say, you know, I have this test, and yeah, it passes 99% of the time. So what? Isn't that good enough? No, because if you if you have a continuous integration system, you'll be running this test several times a day in several different configurations. In the course of a week, you might run this single test hundreds of times across many different platforms. So therefore, this, you know, you think 99% is pretty reliable. But it isn't, because this flaky test is going to generate maybe a dozen spurious failures every week in a continuous build system. And then if you have more than one test, if you have thousands of tests in your test suite and a handful of them are flaky, what this is going to do is give you kind of a noise floor of test failures. And so you're going to look at that and say, oh, okay, well, yeah, that's our noise floor, and that's normal. Yeah. And the problem that will occur when that happens is if somebody introduces an actual bug and it causes this test over here to fail regularly, you're never going to notice it.
Yeah.
And so having a noise, having this noise level of intermittently failing tests is going to obscure real quality problems. The problem is, in practice, it is very, very difficult, as you all know, since you all raised your hands, and as we know, it is very difficult to get a test suite that is 100% reliable. But it's really important to work on it. And so I think there are no magic bullets here. I think the thing is, if you have to hit it at all levels. If you're reviewing test code, and you should be reviewing test code, but when you're reviewing test code, you can look at it and say, oh, is this a potential source of intermittent failures? Yeah. And they do creep in. Occasionally people will put, oh, I can't test all of them, so I'll use a random number generator. Yeah. Well, okay, so that's a source of intermittency. People will, it's hard to imagine, but people will inadvertently introduce intermittent failures from time to time and not realize it. Sometimes there's sensitivity on the environment that you have to build up robustness in the tests. So there are a lot of things that, there are a lot of damaging things that can occur if you have a test suite that is not reliable. And it'd be nice to be able to wave a magic wand and say this test suite is reliable, but I think what you need to do is just get down and do the work.
Yeah. So I have a question for you.
Yes.
Do you ever look at tests that have been written from this point of view? Do you consciously think about the design of a test to see whether it's actually deterministic, or do you think you probably just deal with it when it goes wrong?
Well, so when I arrived working on the JDK, it wasn't my test suite only, but there was a large test suite, mostly written by people long ago, and so what we did was we worked on tests that attracted attention by just gathering statistics over how frequently those tests failed, and then examining the ones that failed most frequently. And I think that's a very pragmatic approach. The problem is that if you have a large test suite, sitting down and attempting to review all of the tests is just impractical. Yeah. So we looked at the tests that attracted our attention. But another thing is, I think it is important to we don't have a specific slide on this, but I think it is important to consider code reviews of tests. Yeah. People have code reviews for product code. You should also have code reviews of tests. Yeah. And there are occasionally times to use randomness in test cases. That's fine if it's well controlled. But in particular, one thing I remember is somebody introduced a test that tested a random set of test cases, but it had an off by one error. And so if you look at the code very carefully, you'd realize, oh, in this case, it'll index off the end of the array. And so that means, and then you could do some statistics, this test will fail 1 out of 1,000 times because there's a bug in the test. Yeah. And so, so I'd like to think that I contributed to the reliability of our test suite by preventing that test from going in, by fixing that test before it actually was checked in. Yeah. So, are there environments like the cloud, for instance, where
how many people? So how many people are deploying to the cloud? Oh, okay,
half.
Okay. So the generalization about cloud is it's a different environment every time, right? And if you go look at Amazon or IBM's SoftLayer or any of these cloud provisioning things, the chances are you're running on a multi-tenancy environment. You're running in a different data center. You're definitely running on a different machine every time you fire up a VM. If you have Docker containers, you're still deploying them in places and the underlying infrastructure changes. And you can be absolutely certain that you won't get absolute repeatability. There's no doubt about it. The cloud actually amplifies this. So this is classic quote by the Amazon guy, who I can't remember his name now, who says, everything in the cloud breaks all the time, right? And it does. And it breaks in ways you would not believe. So, so the classic is you have two machines, okay? And machine A can see machine B and can talk to it, and machine B can't talk back to machine A. And then suddenly it flips, right? Or you get this guy can talk to this, and you get different timing routes, you get all sorts of weird stuff. So absolutely, in the cloud, you have to accept that your tests are going to fail for weird reasons. And in those sorts of environments, you may not even want to debug it because it's just intermittent. But at a higher level, you have to accept all your tests are going to fail one way or another for weird things, right? So you've got to figure out how you write your test case to separate out this is the expected failure that I was looking for versus the droid that it wasn't. So it's unfortunate that's the way it is, and it's just going to get worse because we're pushing everything into the cloud. So you can be defensive by spending more money and buying bare metal and not being multi-tenant, but at the end of the day, the majority of us are going to be running in multi-tenant environments. You look at things like serverless and stuff like that, you've got the same problem. You've got your piece of code is running in some opaque environment, right? And you're going to get failures. It's just built in. Yeah. So I was thinking while you were talking that one of the things that absolute repeatability forces you to do is when you're writing test cases, one of the things that you will do, especially if you have a team that's writing tests, is they will go, I'll put some timers in, I'll put some sleeps in, I'll wait. Right? And what you want your guys to be doing is if you find yourself in that position, your system test team find that, that's an indicator that you need an event. So you need to go back to the product team and go, how do I get told that this has happened, right? And you need to start pushing that back into the process because all of these weirdnesses are going to happen loads and loads of times. And so you need to be thinking about, your product has to deal with them, so you should be thinking about how you start to change the architecture of your product to deal with this environment. Okay, off soapbox.
Okay.
Yeah. Okay. Independent tests only, yes. These are tests that have grown up and will go off in the wild and send you postcards. Independent tests are, well, we all think we write independent tests. We think that it's fine. I can run that test, and then I can run that test, and I can run that test. But in reality, what actually happens is we tend to run all our tests in one single order, right? It's just common, right? And so here's an example of where that broke. So those of you who are of a certain age may remember, there was some time ago, in fact, I wasn't quite sure when it was, there was a change in the JVM. And I think it was to do with, was it get declared methods or something like that?
Get methods or get declared methods, yeah.
So JUnit. JUnit runs test methods. So it makes a call and does reflection, gets the list of the test methods, and it executes them. The order that it gets them back in was defined. Well, not defined, it was just what it was. And then there was a fix in the JVM or the class libraries so that method returned things in a different order. Lots of people's test suites failed. And the reason they failed was because they ran tests in a different order, right? And so what we're saying is you've got to think about writing your tests so that you can execute them in any order. You know, you want the flexibility. It does mean that if you're going to debug something, it's a lot easier because you can just run that test and not worry about having to run some other tests first to set things up, which is a bad thing to do anyway. Where else was it? And it also, you know, like subsetting. That's cool, isn't it? If you can run things independently, when you change some code in this area, you can say, just run those 10 tests. You don't want to be a situation of, I've got to run all these 2,000 tests just to get to the 2 that I want to test. No, you want to be able to run them separately. You know, it makes perfect sense to me. So have you had any problems in this space?
Oh, yes. Yes, definitely. So before I dive into that, though, I wanted to observe that. So on an earlier slide, we talked about when you write a test, have it do one thing. This is kind of the opposite of that. So instead of having, well, I think it's true, right? Write a test that does one thing instead of many things, but also have a bunch of tests that are all independent of each other. And so it's kind of the dual of the other thing. And so, again, maybe this is sort of an obvious thing, but maybe it's not so obvious because we keep running into this, right? So just recently, we stumbled over yet another test in our test suite where it was, this is OpenJDK, right? So it was a test that was testing some subsystem, and the way it configured that subsystem was by writing a configuration file into the JDK that was under test. And it left it there. But it passed. So that's okay, right? It passed. We have a passing test, right? Well, the problem is that particular configuration caused some test downstream to fail. And so bug was logged, and some of our the quality team took a look at it. They said, oh, this test is failing. Okay, so they ran the failing test. Worked perfectly. Well, why is that, right? Well, so now they have to do some detective work, because it's like, what could have caused this test to fail, because we can't reproduce it when we run it on a clean JDK. Well, so it turns out that there's this it's really a false dependency, but it's a dependency between these tests where one test had a side effect that caused some other test downstream to fail. And so it's a clear violation of independence. But it's also, there's, I think, something more fundamental, which was so obvious we didn't even bother to say, which was, don't modify the system under test.
Yes, that's true. Yes.
Forgot about that one.
Yeah.
I mean, some of these, if you've been testing for a long time, there's some of these things that are just so ingrained,
Yeah,
right?
yeah.
And so don't modify the system under test, and certainly don't don't have a test that leaves modifications persistent, because it can cause tests downstream to fail.
Yeah.
And so anyway, so that was, I'm not sure how long they spent on that, but it was a lot harder to figure out than it should have been, because if you have a test that fails, you should be able to run the test and have it fail again, and that wasn't the case this time.
And if you look at, we said about the structure of your tests, you've got setup processes, you've got teardown processes. If you've got tests where you're going, I have to run this test after this test, it's because you've got a setup problem. So you should better abstract the problem away, right? And again, you've got things like mock objects. So there are ways of faking out your environment to test the bit that you want and to take more control. And mock object can be quite useful in the non-determinism as well, because you can remove some of the weirdnesses. Right. Okay.
All right.
Next one, number 8.
Okay. All right. Provide diagnostic tests on failure. Yeah. Okay. So this is an obvious one. One of the things I hate is a lot of where do these all come from? It's like, oh, I hate it when this happens,
Yes.
right? And so one of the things I hate is when you get, oh, this test failed. So you go look at the logs and it just says failed, right? We had this problem where we'd have these tests where there'd be some complicated multi-process thing and something would time out. And so you get this whole log and it said, test failed, timeout. Why did it time out? What was it doing when it timed out? What was waiting for what when it timed out? I don't know, right? So now we have a huge debugging problem. So the lesson here, or the recommendation here, is to pay attention to what information is going into your test logs and provide as much diagnostic information as you possibly can. Now, so for most Java tests, especially unit tests, this is pretty good, because when you say assert true or assert equals or something like that, you get an exception stack trace, and usually the position of that, you get the exact line at which the test failed, and usually it's clear from context what failed. And so most of the time that's not a problem. It's the uncommon cases that get you, right? So in that case, the usual problem is if an exception is thrown, that indicates a test failure, or, depending on how you classify it, a test error. And so again, a stack trace will point you right at the place that it failed. Great. Excellent information. There's an uncommon case, for instance, which is you want to test that an exception of the proper type was thrown from the proper location. And it's a little too easy to say, oh, I'll just use like a JUnit annotation, or I'll put a try block around a bunch of stuff and catch an exception and make sure that it was the right type. But the problem is that it's a little too easy to do that and accidentally catch exceptions that originate from the wrong place. And in that case, what you have to do is you have to tear apart the test and figure out, in particular, the case. Suppose there's a case where somebody wants to make sure that illegal argument exception is thrown. But if there's a whole block of code, how do you know that illegal argument exception was thrown from the right place, the one that you were expecting, instead of, say, maybe something went wrong with your setup code that also threw illegal argument exception? Yeah. So anyway, so there are cases like that come up where if you have a failure, make sure that, sometimes it's not so simple as just saying assert equals. Sometimes you have to go through a fairly complicated algorithm and then decide, okay, yes, I'm going to explicitly signal failure here. And when you do that, make sure that you write down enough information to say how you got there. So Steve, what's your experience with this?
This is where I was screaming in the dark. So I have, so you love this. I mean, this is just terrific. So very long time ago, I just joined IBM, hadn't been there very long. And
Oh, very long time ago then.
very, very long time. Yeah, you know, when computers were wooden, I know. So it wasn't a Java story because Java wasn't around then, but it's very, very sort of to the point. I was asked, there was a bug, and the bug was something along error code 53, right? And it came out, IBM, a lot of IBM products have this thing called FFDC, first failure data capture. The idea is, in support of this, when it goes wrong, give me a unique string that will let me get back to the piece of code that's failing. And also, it means that if there's already a fix for it, it's very easy to spot it. I've automated that process. So we have a problem with that. And I get this, can you figure out where this error code 73 or whatever it was coming from? So I start digging, and I dig and dig, and I discover that the product has its own error handling system. And eventually, after a long time, I realized that because this error handling system was being used everywhere, and it was generic, it meant that my error code 73 could have come from any line in the product, right? And I'm sitting there going, because it was late. I remember this. And eventually I got down to understanding that it was even worse than that, because this error code, whatever it was, 73, wasn't even a product error code. It was just sending up a return code it got from some I/O call. So I didn't know. All I had was a number, and I had no idea what the problem was. We didn't know where in the product was being thrown, and we knew that it was coming up from the operating system, but we had no idea what call was being made. Right? And I went, this is really cool, lovely, yes. So I would say, I mean, that's the extreme case. But actually, you've got to have this information. When it fails, you've got to be able to quickly get back to the problem, right? I would also say that it's also a way that you should be looking at whether your product is giving you the error information you want as well, because we all know that a really great thing that happens is that when there is a failure in the product, there might be some logging information to report it, and 9 times out of 10 that's going to fail because that never get tested. So actually, the programmer who's created the product and the error handling code didn't test it, right? Because he didn't think about, that field is null when in fact he thinks it shouldn't be null, but it is null. So that line of code fails, and so you don't get any error report. Okay, it's just horrible. Everybody must have had that experience. Yeah. Cool. Right. 9. No hard coding of your environment. Another war story. I'm glad you're all sitting down for this one. Okay. So, when you have a big product, you run lots of tests. When your big product is the underpinnings for other big products, they run lots of tests. And there's always this fight about, well, if you would just run our test, you'd find our bugs quicker. Because back to your point about if tests take a long time to run, then the chances are that the thing, when the test is discovered, it's so far down away from what the code the developer's changing. So it might be weeks, it could be months, and the developer's so far down again, I have no idea, right? So you get this pressure, and we all do it. We all look for ways to find the bugs quicker, and so like we did this with Java, with modularity, is like going out and finding all these product external open source things and saying, could you test for us? So imagine that scenario, okay? But imagine it writ last. So I have a large product, and they said, would you run our test for us? And we went, okay then, right. So we got these tests in, and we ran them up, and it went, what's a C drive? I can't find C drive. Oh, we're running it on Linux. Oh, you ran it on Windows. Oh, that's not good. Okay, so we started to fix these, right? And then you start finding things like, oh, what do you mean you've got a local NFS mount? Oh, we haven't got one of those. Or you've got a local, there's a system that you're referencing. We haven't got one of those. Hard-coded, right? We spent the equivalent of about a man-year going through many tens of thousands of tests, going, oh, that one's hard-coded. It's making local assertions. And it just kills you. So, I mean, it's silly, but actually portable tests in the new world, back to the cloud stuff, you're going to run your tests. You're going to want to run your tests in these environments that are different. If your tests aren't portable, right, then you're dead in the water. So you have to resist the urge to hard code stuff, right? At the very least, have a configuration file. But hard coding isn't just Linux versus Windows. You know, it's all these other things. It's like, what's the URL for a system? What's the port? You know, what database are you using? Where it doesn't make a difference to your application, you need to find ways to abstract it out so that you can change it, because it is going to change. So can you think of any reasons why you might not want to hard code your environment?
No, it's pretty hard to. And actually, one observation I have after talking to this guy for a while is, if you're sharing war stories with an IBM guy, you can never win. No, I mean, hard coding the environment, don't do it. I mean, kind of the only thing I can think of that's even close is sometimes you have to hard code things like ports, because there are various things that are on well-known ports, and you might want to have some function whose semantics are the default port is 80, and you want to test that the default port is 80. So you kind of have to hard code that. And that means that anything else running on port 80 is going to interfere with it. So, but aside from that, yeah, try to avoid hard coding at all costs.
Yeah, it does bite you in other ways. There was that little problem with MongoDB where the port was hard coded, and all the product teams. So all the guys that have written code that talk to Mongo were expecting to use a certain port, and then there was a security exposure, and it was like, well, could we change the port number? You know, no, because all these products assume it's going to be exactly that port number. So you know, there are times when it's just hard coding and nothing you can do about it, but that's not an excuse. It's just a situation. Yeah. Right. Next, the last one. No extraneous output.
Yeah.
Stuart.
So I think this mainly applies to unit tests. If you have a set of unit tests, like 10,000 unit tests, you don't want those unit tests writing out verbose logging. You want those to be silent, so at the end, I ran all 10,000 unit tests and they all passed. Great. On the other hand, I think if you have a big complicated system test, like that one that had that timeout I was talking about before, sometimes a test is so complicated it needs to do verbose logging about everything it does, because if it does end up in the case where it's timing out, you need to know what it was trying to do when it, before it timed out or before it got some unexpected failure. So I would say this is mostly true, but it also depends on what kind of tests you're writing.
Yeah.
So, Steve.
Yes, this is one of those others. So you don't really, if you run tests and you put out lots of logging, or you put out lots of information, I've loaded this file, I'm doing this, and we all do that, because you're sort of saying, how far through the code did I get, right? The trouble is that when you do that by 10,000 tests or 100,000 tests, then you won't spot if it changes. So the main thing is that you're asserting to yourself, the right word there, that your test, because your test said it passed, that it passed. But sometimes you have tests that fail, but they say they passed, right? You get an exception in the log. Now, if your log is quiet, then you'll spot that. If it's busy, then you may not, right? And I think it's the main thing I have with this, is that I would prefer to rely on the test suite framework to tell me the test passed or failed, and then look at the log. And if the log's not empty, I would say, okay, I'll go do some investigation, right? And we don't do that. We tend to go the other way. We tend to put stuff out like that. And the consequence of that is that it can be harder for you to spot these failures. And if you're running this in large environments, then you end up investing in tools to analyze your logs to see whether it can find problems, right? And it's like, well, we just made a problem for ourselves. So if you could keep your logs as quiet as possible, and I would go for, I'd love to have nothing. I'd love to say all tests passed. I ran 10, and that's it. And that would be great, or 1,000. Yeah. Anything
All right,
else?
I think we no.
Okay, cool.
I think we need to
wrap
up here. Yeah.
Right, wrapping up. So, pirate rules. Okay. So we said there were rules. Well, they're just guidelines, right? Okay. And you may think, they seem obvious. They're worth restating, because you're trying to get back to why it is that you're doing this in the first place, right? And we can be pedant about some of this stuff because we know what the rules are and we know when we're going to change them and why we're doing this. And believe me, you may go, no, this is not a problem. The first time you get hold of somebody else's test suite, you will be writing your own set of rules and going, why did they do this? Why did they do this? It's just terrific. Do you have a wrap up?
Yeah, a little thing. I think ultimately I'm a pragmatist, and what I never want to hear somebody say is, well, those guys from IBM and Oracle said you have to do it this way, so you have to do it this way.
Yeah.
So no, I think these are really good guidelines to follow, but it's also driven by results, because our experience has been if you follow these, you get better test suite, better code, better quality. And it's tempered by what you're trying to do with the test suite and also what kind of test you're writing. And so if you're writing a different kind of test, then maybe this rule makes more sense than that one, or something like that. So I think that's the thing. Keep in the back of your mind why you're doing it, not just blindly following the rules.
Yeah, be sensible about what you're doing.
Yep.
Cool. So before you thank us for giving you the benefit of our wisdom, I would just offer to do my IBM advertising. You can go win some good goodies at the IBM booth. You don't need to do very much, you just need to get some stickers. So there's t-shirts and stuff like that, but there are some nice goodies out there. So, I would suggest you pop along to the IBM booth and maybe you can win a TJ bot, which is the little robot, which is quite cool. VR glasses, a drone, why would you not want to do this? Anyway, so I think we're done.
All right,
so
that's
thank
all
you
I have.
very
I think we're
much.
out. Thank you. Okay.
Have we got time for questions, or are we done?
No,
I think we're out of time.
We're over already. So.
Yeah, sorry. We'll be around, so if you want to ask any more, we're at the conference most of the week, so just catch us or catch me now. Cool. Thanks very much.
Thank you.